Alright, number 7. Use the topographic map below to predict how the landform may be reshaped by weathering. So if you were to analyze this, this is actually two mountains. So here's the peak of one mountain, here's the peak of another, and it's actually really steep right here and kind of gentle down here. So let's look and see how, predict how the landform may be reshaped by weathering. So weathering could reshape the top of the landform to increase elevation. That doesn't make sense because weathering means to break down. So we're not even gonna mess with that one. Like that's, that's not the right answer. So mark out A. So weathering could reshape the top of the landform to decrease elevation. Well, possibly, because whenever you look at it from the side, if that's your mountain, you have wind that comes and takes away the sediment from the top. So decreasing it in elevation is actually a big possibility. Weathering could reshape the right side of the landform to create a cave. Probably not. More than likely that will happen with water crashing up against like the side of like a really steep mountain. So I'm not really gonna get into that. There could be several different outcomes of that. And then D, weathering could reshape the landform to create a canyon. Well, we know that water creates canyons, rivers create canyons, so the correct answer here is B. Alright, number 8. Alfred Wegener noted that fossils from a particular type of reptile were found on both sides of the Atlantic Ocean. Which of the following would be the best explanation of how this occurred? So, if you'll remember, I made you do a puzzle a long, long time ago. And one of the things that you should have noticed is that you have Africa and you have South America. And both of those kind of look like they might fit nicely, kind of right butted up next to each other, okay? So this big landform, we named it Pangaea. So, Pangaea, does that mean they swim across the ocean? Nope, because Pangaea was one big landform. The Atlantic Ocean did not exist in earlier times. Okay, yes. H, they walked across a giant land bridge. No, definitely not. We've never talked about that. And then J, they walked across an ice bridge located near the equator. Well, we know the equator's hot, so there's definitely not going to be ice around there. So just through the process of elimination, we know that the answer is G. The Atlantic Ocean did not exist. Alright, whenever we come down here, we're going to use the following model for the next 3 questions. So let's just kind of analyze this right here. So you see the letters, and they're actually referring to the landforms that are on top of the plates. The Roman numerals are referring to the plates themselves. So number 9, where would the youngest ocean floor be found? Okay, so let's look right here. Right here, we see a divergent boundary because you see like these little white spots right here. That's actually the lava going up, just like right here at the volcano, the lava is going up. So right here, I know that there's a divergent boundary. At divergent boundaries, we have this magma coming up and spreading. So that's actually making new crust in new plates. So Roman numeral 3 is C. So that is your answer for number 9, where the youngest ocean floor can be found. It's along this divergent boundary. Okay, number 10. Which area on the terrain above would show an area with a divergent plate boundary? Well, we just kind of decided that 3 has the youngest ocean floor and that this is a divergent boundary. So the landform that's going to go with that is actually letter C, okay, and that's going to make an ocean ridge. So we kind of answered both of our questions by just analyzing the picture. Number 11, where would the ocean floor be the oldest? Okay, so we know at a divergent boundary, this is going to be the youngest right here. Then you're going to have older, oldest, and eventually you'll have your ancient crust that's going to be recycled back down into the mantle. So over here at Roman numeral 2, that is where you will find your oldest floor, because remember, as your new crust is over here, and the plates are moving because of slab pull, because of the convection currents in the mantle, okay, you know that this is the newest, and over here will be the oldest, so Roman numeral 2. Okay, this is a lengthy one. I feel like a lot of you just decided that it looked like a hard question because there was a lot of information, so you just decided not even to read it or try to analyze it. So you've got to get in the habit of doing that, or else you're not going to do very well on the STAAR. So get in the habit of it now. So it says, use the following scenario for the next 3 questions. The following is a model of how a volcano is formed in the ocean. Clay is used to represent lava coming out of the ground. The clay is pushed through a hole in the bottom of a fish tank. The following forms. So where you see this dotted line, that's actually going to be like some kind of medium, probably water. Okay, the hole is down here and they're pushing clay up. So initially at first you won't even see the clay because it's below the water. Then the clay starts to kind of get, the more it gets pushed up, the bigger the mountain it makes. So it says you can see how the clay comes through the bottom and slowly forms an island that is above the water. Afterwards, fishing line is used to cut off pieces of the island to show how the volcano will weather. Okay, well, we know in this first one, we're not going to see any landforms above the water because the clay is still below the water line. So this could be very much representative of what it would look like as a bird's eye view here in this picture of picture 1. Picture 2. So you see that the clay is starting to kind of poke up out of the water. So this is very characteristic of picture 4. This one right here, you see like the full mountain right there. So we're going to go ahead and try to say that that is number 2. Now the reason I say this is number 3 and not number 4 is because this is much wider at the base than this one. So I can tell that this is number 3 because this one is wider across than number 4. And then this one right here, it's been completely weathered down and it's back below the water line. So this one would be number 5. So number 12 says, which of the following series of topographic maps represents the formation and weathering of the volcano in the clay model? Okay, so I pretty much just answered my question right here. So can I find these numbers in order? 1, 4, 2, 3, 5. Yes, it is actually J. So number 13, how would this model represent an advantage for a topographic map? So I actually did this for you in class last Friday, I believe. Maybe it was earlier. Yeah, it was last Friday. So we got out the tank and we filled it full of dirt and I actually had it full of water and we were taking out the water and I was having you draw around the dirt as it was appearing. So what I was trying to get you to do is visualize topography. I don't really care about how clay pieces get cut off or how it shows how clay grows because clay doesn't grow. It's not organic. And if you ever see a none of the above, more than likely it is not that answer. So go ahead and cross out D. It is not none of the above. That's too easy. That's never going to be the right answer. So focus on something other than that. So the only reason we would have a model like this is so that we can visualize the topography. That's why we have these illustrations right here.